Welcome to a video on finding the domain of combinations of functions. To find the domain of f minus g, we need to find the domain of the individual functions first and find their intersection. Note that for this problem, the function f and g are defined as follows. F of x is defined as x squared minus 5, and g of x is defined as the square root of 3 minus x. So to find the domain of the function f, let's denote that as d sub f for the domain of the function f. This is a quadratic function, which means that there are no values of x that will make this function undefined, and therefore its domain is a set of all real numbers, an interval notation that's from negative infinity to positive infinity. For the domain of g of x, we'll denote that as d subscript letter g. And because this is a radical function of an even index, we need to make sure that the radicand is non-negative. So that means 3 minus x must be greater than or equal to 0. Solving for this inequality, we'll add x to both sides, resulting in 3 is greater than or equal to x. This statement says it's a set of all x values for which x is less than or equal to 3, and therefore in interval notation that's from negative infinity to 3 inclusive of 3. So now that we have the domain of f and the domain of g, we want to find the intersection of these two sets. Let's sketch these two sets on a number line. So if this number line represents x, the domain of f is a set of all real values. Let's go ahead and highlight that in blue. That would be everything from negative infinity to positive infinity. And for the domain of g of x, let's highlight that set in yellow. So that's from negative infinity up to the value 3, inclusive of that. And therefore, on the number line, that would be everything up to the number 3. Hence, you can see that the intersection of these two sets is a set of all values between negative infinity and 3. And therefore, that's the domain of f minus g. So I'll denote that as d subscript f minus g. For the other part, the domain of f divided by g, again, let's denote that as d subscript f divided by g. By its definition, it's also the intersection of the domain of f and g, which means, again, the overlap of these two sets, which we can see on the number line, is this set right here, but provided that g of x cannot be 0. Otherwise, f over g is undefined. So we have a further condition, which means that we need to solve for the values of x that will make g of x 0. So provided that 3 minus x under the square root is not 0. Solving this inequality means that 3 minus x cannot be 0 by squaring both sides. And now we have a further condition where x can no longer be 3. So we basically take the intersection of the domain of f and g and exclude this number from that set. So its domain now, domain of f divided by g, that is from negative infinity to 3, exclusive of 3. We'll use a parenthesis to indicate that.